In our last video, we looked at pushing this box with a 50 Newton force. In this example, I've now changed that 50 Newton force to 200 Newton force. So you might need to go back and watch the last video if you haven't seen that one before watching this one. We wrote the sum of the forces in the y direction, and we got that the normal force is equal to mass times gravity. That still applies in this case. These forces stay the same in my free body diagram. What changes now is my 50 Newton force from before now becomes a 200 Newton force. So our x directional forces are going to be changing. We also said that the force of static friction is less than or equal to the static coefficient of friction times the normal force. And in this example is 98.1 newtons. Well, here we've obviously, our 200 Newton force exceeds our 98.1 Newton force, and so we're going to start accelerating. Our box is going to start accelerating. And so this question now asks, what is the force of friction on the box, and what is the acceleration on the box? Well, when we're moving, we know that the force of friction is equal to mu k times the normal force. In this case, we have that's equal to mu k times mg, or 73.6 newtons, using our mass of 50 kilograms and 9.81 meters per second squared for gravity. So then, if we write the sum of the forces in the x direction, that's equal to mass times acceleration. This time, our block is accelerating because we have exceeded the static friction, and so we can't say this is equal to 0. We can say that it's equal to our 200, come on, equal to our 200 Newton force minus the force of friction, which we said in this case is 73.6 newtons. If we plug in our 50 kilograms for our mass, we can then solve this. We can say acceleration in the x direction is equal to 200 newtons minus 73.6 newtons divided by 50 kilograms. And we get the acceleration in the x direction is 2.5 meters per second squared.